So this video is designed to show you not what the area formulas are, but where area formulas come from. We all start with the basic formula of a rectangle. The area of a rectangle is base times height. So in this case, I don't have a rectangle, I have a parallelogram. But if you notice, this is like my base down here, and then I have my height up here. So watch what happens when I press run. What's going to happen is, we're going to chop off one side of the parallelogram and slide it across to the other side. Notice the shape that we get. We end up with a rectangle. So just like a rectangle, the formula for the area of a parallelogram is base times height. So let's move all that back. Come on back, baby. All right. So now let's move on. Let's take a look at the area of a triangle. So again, I have a triangle here, and the area of the triangle, well, let's see. This is my base. This side is my height. Remember, the height of a triangle is perpendicular to the base, so I got a little right angle there. So watch what happens when I press run. A new triangle is created, and it spins around. So what shape do we make? Can you see it's a parallelogram? Fantastic. Now, the parallelogram is the whole area. The parallelogram is two of the triangles. I only want one triangle. And that's why the formula for the area of a triangle is only half base times height. Because if you do base times height, you get two triangles. We only want one triangle. So that's where that area formula comes from. Let's spin that baby back. So now we get into some fun things. Let's talk about a trapezoid. So this is one of those formulas that I always get confused at trying to remember, because there's a lot of things going on in here. First of all, there's a height. There's a base that we'll call like base number 1, or we'll call it B1. And then there's another base number 2. And maybe you want to call it B2. So let's run and see what happens. What it's going to do is it's going to create a second one, and it's going to flip over. What shape do you see? Oh yeah, it's a parallelogram. And what's neat is that this is base number 2 because it flipped over, and that's base number 1. So remembering from before that the area of a parallelogram was base times height. In this case though, this big old base here is B1 plus B2. That's the length of the entire base. So the area of the whole entire trapezoid, or the whole entire parallelogram, is base 1 plus base 2, that sum, times the height. But again, we don't want two of them, we only want one of them. So that's why when we do the base 1 plus base 2 times height, we're going to divide it by 2. We're going to take half of that value. Pretty cool, huh? Bet you didn't know that one. But wait, there's more. Let's talk about the area of a kite. I see a whole bunch of right triangles in there, so I can do a couple things there maybe. So what I like to do is I like to think of this segment right here as being diagonal number 1. And then the other diagonal, the one that we'll do maybe in green, woo, that's diagonal number 2. So I got diagonal number 1, I got diagonal number 2. How do I find the area? Watch what's going to go on. So first, I'm going to flip my two bottom triangles over, and then I slide it up. So can you see that these two triangles are the same, and that these two triangles are the same as well? Cool. And now I got myself a rectangle. So how do I find the area of a rectangle? How do I find the area of this red rectangle here? Well, it's base times height. It's diagonal number 1 times only half of diagonal number 2. So notice that the height of it is only half the other diagonal. So that's why our area formula is 1/2 times diagonal 1 times diagonal 2. Half the product of the diagonals. It's one of my favorite formulas of all time. So one last one, and this is my favorite of all. I know I say that all the time, but this one is going to be really, really cool. Wait till you see this. Have you ever seen how the area of a circle comes about? Well, it has to do with pizza parties. and little kids' pizza parties. So what I'm going to do is I'm going to slice this pizza up. I'm not going to slice into like 8 slices like a normal pie. You ever go to a kid's birthday party where there's like 16 slices, or maybe even, we'll go up to like 32 slices for this example. And what I'm going to do now is I'm going to unwrap it. Whoop. Check it out. And then after unwrapping it, I'm going to grab this top section and I'm going to scoot it right in there. Holy cow, that's a parallelogram. All right, well, let's talk about some things that we did first of all. Okay, let me go back a little bit here. So from this part here, remember that the distance all the way around the circle is called the circumference. And circumference is called 2 times pi times the radius, 2 pi r. So when I unwrap this thing and I pull this thing over, what I really have, I know it's a parallelogram, but it's not really a parallelogram, because if you ride along this road is not a flat road. What that road does is it goes a little bumpy. It goes like ba-bum, 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 because it's got a little curve to it. So this distance right here, which I'll kind of represent by a straight segment, even though it's not really straight, that's really half of my circumference. That's pi times radius. And then if I want to talk about the height of this parallelogram, remember the height makes a right angle. So maybe I'll draw my height right in here. And what is that red segment? That red segment's the radius. So it's kind of like a parallelogram where you do pi r, the base, times r, the height, and that's where our formula is pi times r squared. That's a pretty cool one. I hope you got a kick out of where these area formulas come from.